Hello everyone, welcome to Enviro Pioneers where we try to simplify the concept of environmental science. In this video, we will study about the terrestrial radiation and energy budget of Earth. As discussed in the last video, that in June solstice, the northern pole or the north axis, it is slightly inclined towards the sun, and because of that, the northern hemisphere, it receives more amount of solar radiation in comparison to the southern hemisphere. While in the December solstice, this north pole is inclined away from the sun, and because of that, the southern portion, it receives more amount of solar radiation in comparison to the northern hemisphere. And the other aspect which we discussed was the angle at which these sun rays are falling on the horizon. More vertically these rays are falling, more intense is the radiation in comparison to those places where the sun rays are falling at a slant angle. One thing which we missed in the last video is about the land of the midnight sun. Land of the midnight sun, it refers to all those locations or all those places which are located in the north of the Arctic Circle or south of the Antarctic Circle. अब ये क्यों होता है? यहाँ पे हमने जैसा देखा कि जो जून सोलिस्टिस है, आर्कटिक सर्कल इट रिसीव्स 24 आवर्स ऑफ डे लाइट, और वही दिसंबर सोलिस्टिस में जो सदर्न हेमिस्फीयर में अंटार्कटिक सर्कल का जो रीजन है दैट रिसीव्स 24 आवर्स ऑफ डे लाइट. तो ये ऐसी जगह है जहां बिकॉज ऑफ continuous daylight you can observe the sun in the midnight also, and closer a place is towards the pole, यानी आप पोल के जितने पास हो the longer is the period of continuous daylight. इस इमेज में we can see the sun at different altitude in the horizon from 6 p.m. to 6 a.m. and in the midnight also we can see the sun in the horizon. इसीलिए all ये जो definition है that any place or any location which is located north of the Arctic Circle, that is towards the North Pole, and south of the Antarctic Circle, that is towards the South Pole, these receive 24 hours of daylight, and we can see the sun in the midnight also, and because of that these places are referred as the land of the midnight sun. The amount of solar radiation reaching at any particular place, it varies from season to season, because the season, it determines that how much amount of radiation will reach at that particular place. So here if we see for the earth horizon, the path, the apparent path of the sun, it seems to change from June solstice to equinox and to winter solstice. So as the earth rotates on its axis, the duration of the daytime, it also changes. अब यहाँ पे this circle, it is representing the path of the sun in the June solstice. ये आपका equinox हो गया और ये December solstice हो गया. Not only the path but also जो sun का altitude है, यानी sun की height with respect to the earth horizon, and the place of the sunrise and the place of the sunset, it also seems to change. Now these three diagrams, these are for a place which is located at 40-degree latitude. So here we have, this is for the summer solstice. So here we have the longest day, because during the summer solstice it is tilted towards the sun. Now here we have the longest day, and at the noon the sun rays are making 73.5 degree, that is near to the vertical, while for the equinox we are having the path of the sun is also changed, as well as the sun angle, the noon sun, the sun rays are making the 50 degree, while in the December solstice this path is again changed and the noon sun is making only 26.5 degrees. So more vertical the rays are, more intense is the solar radiation falling at this particular place. So in December solstice or in the winters, the sun rays or the solar insolation at this particular place, it decreases in comparison to the summer season. So this is the daily path of the sun for a place which is located at the 40-degree north latitude. While this one, it represent for the summer solstice at the 80-degree latitude. So here we have the, because this will be having the continuous daylight in the June solstice, Arctic Circle, or towards the North Pole. So here we are having the noon sun and then midnight sun, because this place is being illuminated by the sun throughout the day as well as night. Now not only from season to season, but अगर हम दिन में भी देखें एक particular 24 hours में, then depending upon the time of the sunrise and the time of sunset, we are having the maximum amount of solar radiation reaching to the earth in the noon. Now this image is for equinox, where equator it receives maximum amount of solar radiation in comparison to the northern or the southern hemisphere. But if we observe or if we see from 6 a.m. to 6 p.m., then as we are having the sunrise, the solar radiation reaching to place, it increases. It is maximum at the noon and then again it decreases. And because of the spherical shape of the earth, on any given day, only those places which are located along a particular latitude will receive the vertical rays. As we saw for the summer solstice, it is 23.5 north. For equinox, it is equator, while for the December solstice, it is 23.5 south, which is receiving the vertical rays. So all those places which are located at this particular latitude will be receiving the vertical rays and maximum amount of solar radiation. But as we move either towards the north or towards the south, the sun rays, they strike at a decreasing angle, and thus decreasing the amount of solar radiation reaching per unit area, because more the vertical rays are, these will be spread in the smaller area, but when these are uh, but when these are falling at the slant angle, they will be spread, the sun rays will be spread in the larger area. So if we compare for the June and for the December, the solar radiation per unit area in the June will be much higher in comparison to the December, because in December or in the winters, the sun rays are falling at the slant angle. So in this image, we can see that how the peak energy received at different latitudes, it changes throughout the year. So here we have the equinox condition, June solstice, then again equinox, and then December solstice. And this represent the amount of energy reaching at the earth in different seasons. So if we observe for the equator, the peak energy, it changes very little throughout the year. There is very little fluctuation. But if we see for the 60-degree north or for the 60-degree south, the amount of energy fluctuation is very high throughout the seasons or throughout the year. So the annual amount of incoming solar energy, it varies considerably from the tropical latitude to the polar latitudes. Now coming towards the average value of the solar radiation reaching to the earth. Now as we discussed earlier in earlier videos, that the solar constant, that is the amount of solar radiation reaching at the top of atmosphere, that is 1367 watt per meter square. Now this is for a circular area, but अगर हमको इसको अर्थ स्फेयर के लिए कैलकुलेट करना है, सो द सेम अमाउंट ऑफ एनर्जी इज नाउ डिस्ट्रीब्यूटेड ओवर अ स्फेयर। तो अभी इसका एरिया हो गया 4πr²। तो अगर हमको ये एनर्जी यहाँ तक कितनी पहुंच रही है और इस पूरे स्फेयर पे कितनी डिस्ट्रीब्यूट हो रही है, अगर हमको वो कैलकुलेट करना है, तो हम ये सोलर कांस्टेंट की वैल्यू को बाय 4 डिवाइड करते हैं। नाउ हियर दिस वैल्यू इज गिवन 1368 एंड इफ यू डिवाइड इट बाय 4, तो ये हमारी वैल्यू हो गई 342 वॉट पर मीटर स्क्वायर। सो यहाँ पे मेंशन है कि अगर हम पूरे अर्थ के लिए अगर हम इसको एवरेज आउट कर रहे हैं, तो amount of sunlight reaching or arriving at the top of the earth atmosphere, that will be 342 watt per meter square. Again you will find anomaly in the values of this particular, जो हमने यहाँ पे 342 लिखा है या यहाँ पे डिस्कस किया, कहीं आप जब वेबसाइट पे रेफर करोगे दिस वैल्यू यू मे फाइंड 340 और 341। नाउ दैट इज सिंपली दैट आप सोलर कांस्टेंट कितना ले रहे हो। जैसे हमने डिस्कस किया था कि कहीं पे आपको 1360 है या 161 है, देन इन दैट केस द वैल्यू आपका जो स्फेयर एरिया पे अगर हम वैल्यू कैलकुलेट कर रहे हैं तो वो 340 होगा। बट इफ इट इज 1367 दैट द वैल्यू विल बिकम 341.75। यहाँ इस इमेज में दे हैव टेकन 1368 and accordingly for the earth it is 342. So we can take that the average value of the solar radiation reaching at the top of the atmosphere for the planet, it is 342 watt per meter square. And this is very important in calculating the energy budget. यानी हम जो भी energy budget incoming solar radiation की बात करते हैं, we consider it as the incoming value or incoming solar radiation for the earth. Now of the total amount of radiation जो 100% यहाँ पे है, that is the 342 or 340 watt per meter square. Now this incoming solar radiation of this 30% is reflected back into the space, some from the atmosphere, some from the cloud, and some from the earth surface. So here we have the 6% is reflected by the atmosphere, 20% is reflected by cloud, and the 4% is the reflectance from the surface. And the 19% of the energy of this coming solar radiation is absorbed by the atmosphere, and then 51% it reaches to the earth and it is absorbed by the earth. Now albedo, it is a scientific term which describes the reflectivity of a surface, and it is mainly used in the astronomy or the earth science. So the albedo, it represents the reflectivity of the surface on the earth, and it is simply the fraction of incoming light which is getting reflected. यानी कि कितना, फॉर एग्जाम्पल अगर हम कहें कि x अमाउंट ऑफ रेडिएशन अर्थ पे फॉल कर रही है या किसी सरफेस पे फॉल कर रही है, तो उस रेडिएशन का कितना परसेंट बैक रिफ्लेक्ट हो जा रहा है, सो दैट इज रिप्रेजेंटेड बाय द एल्बिडो। मोर हायर इज द वैल्यू ऑफ एल्बिडो, इसका मतलब कि रिफ्लेक्टेंस उतना ज्यादा है। नाउ टोटल रिफ्लेक्टेंस जो हमने यहाँ पे 30% देखा, this is referred as the planetary albedo. So planetary albedo, it is combined figure for the earth जहाँ पे हम atmosphere plus surface दोनों को कंसीडर कर रहे हैं, यानी कि एटमॉस्फेयर से, क्लाउड से, सरफेस से टोटल जो हमारा रिफ्लेक्टेंस है अर्थ का, उसको हम कहते हैं प्लेनेटरी एल्बिडो. So it ranges from 30 to 31%. So in this diagram we have the albedo for different earth features. जैसे कि आपका यहाँ पे fresh snow है, so the value is 80 to 95%. मतलब कि जितनी भी radiation इस पे fall कर रही है उसका 80 to 95% जो है वो reflect हो जा रहा है. Now grass they have 25 to 30%, यानी जो remaining है वो absorb हो रहा है और 25 to 30% जो है वो reflect हो रहा है. Now forest is 10 to 20%, crops or grassland 10 to 25%, asphalt यानी कि जिससे रोड बनती है that is 5 to 10%, concrete, dry concrete that is 17 to 27%, then अगर dark roof है it is 8 to 18%, light roof is 35 to 50%. यानी कि जो लाइट रूफ है दैट विल रिफ्लेक्ट मोस्ट ऑफ द रेडिएशन. And then water bodies, it may have the albedo from 10 to 60% depending upon the variation in the sun's altitude. और जो clouds हैं, again thick clouds हैं तो उनका albedo high है, that is 70 to 80%. और अगर thin clouds हैं तो it is 25 to 30%. So different features on the earth, they have the different albedo. अब जितना portion reflect back हो गया, so that we are representing by albedo, but जो बाकी बचा that will be absorbed by the earth. Now जो पोर्शन एब्जॉर्ब हो गया, ठीक है, यानी कि अर्थ ने कुछ पोर्शन, यानी अर्थ प्लस अर्थ का एटमॉस्फेयर, यानी जो हमने प्लैनेटरी एल्बिडो डिस्कस किया, तो कुछ पोर्शन इनकमिंग सोलर रेडिएशन का तो रिफ्लेक्ट बैक हो गया, लेकिन जो रह गया दैट विल बिकम, और जो एब्जॉर्ब हुआ अर्थ से, मतलब अर्थ ने जिसको एब्जॉर्ब कर लिया जितने पोर्शन को, दैट विल बिकम हीट ऑफ द अर्थ. नाउ दिस हीट विल बी रेडिएटेड, यानी अर्थ अब ये जो एनर्जी है इसको इमिट आउट करेगी, एंड फ्रॉम ऑल एंड इन ऑल डायरेक्शन. ओके, सो ये जो रेडिएशन एमिट हो रही है फ्रॉम द अर्थ, that is referred as the long wave radiation. So long wave radiation is simply the electromagnetic radiation emitted by the earth's surface or the atmosphere or the cloud. Now here if you see incoming sunlight, here we have mentioned short wave radiation, and then we have the outgoing heat that is in the form of the long wave radiation. So this long wave radiation, it is also referred as the terrestrial radiation. And these terrestrial radiation or the long wave radiation, it range from 3 to 100 micrometers. और अर्थ से जितनी भी एनर्जी इमिट होती है, 99% of this radiation it ranges from 4, मतलब 99% जो है वो 4 माइक्रोमीटर से 100 माइक्रोमीटर की रेंज में फॉल करती है. अब अगर हम इसको इस ग्राफ में देखें, so we have this electromagnetic spectrum. Here we have the ultraviolet, visible, infrared and microwaves. अब infrared radiation जो है that can be categorized into near infrared, short wave infrared, mid wave infrared, long wave infrared and then far infrared. Here we have the values. Near infrared is 0.7 to 1.5. Short wave, it is 1.5 to 3 micrometer. Mid wave infrared, that is 3 to 8 micrometer. Long wave, it's 8 to 15. And जो far infrared है, that is 15 to 100. अभी हमने देखा कि 4 से 100 जो माइक्रोमीटर, यानी कि 99% of the long wave radiation, it ranges from 4 to 100 micrometer. As we discussed in the Wien displacement law, that most of the solar energy emitted from the sun are towards the shorter wavelength, while from the earth it is towards the longer wavelength. अब सन से जो एनर्जी आती है उसमें भी हमारा नियर इंफ्रारेड है, अर्थ से जो इमिट हो रही है दैट इज ऑल्सो इन दी इंफ्रारेड पोर्शन. सो एक बाउंड्री सेट कर दी गई है कि एनी radiation which is having the wavelength less than 4 micrometer, that will be considered as the short wave radiation, and if it is having more than 4 micrometer, that will be considered as the long wave radiation. So from the sun we have the we receive the solar radiation mainly in the shorter wave. अर्थ से जो रिफ्लेक्ट हो रही है दैट विल बी ऑल्सो शॉर्ट वेव, लेकिन जो इमिट हो रही है दैट विल बी लॉन्ग वेव. सो दिस इज वेरी इंपॉर्टेंट कंसेप्ट, बिकॉज अगर आप ग्रीन हाउस इफेक्ट पढ़ रहे हो या फिर आप रिमोट सेंसिंग पढ़ रहे हो, तो दिस पार्ट इज वेरी इंपॉर्टेंट टू अंडरस्टैंड कि जो भी रेडिएशन सन से आ रही है और अर्थ से वो रिफ्लेक्ट बैक हो रही है, दैट विल बी हैविंग द शॉर्ट वेव, means that will be short wave radiation, but if it is emitted from the earth that will be the long wave radiation. So this 4 micrometer, आपको ये याद रखना है कि any electromagnetic radiation that is having the wavelength less than 4 micrometer उसको हम शॉर्ट वेव रेडिएशन कह रहे हैं, और अगर उसका वेवलेंथ 4 माइक्रोमीटर से ज्यादा है तो दैट इज द लॉन्ग वेव रेडिएशन. Now coming to the Earth's energy budget is simply the balance between the incoming solar energy as well as outgoing radiation. So outgoing radiation is in the form of the reflectance and the emittance. So of the 100%, if we consider the incoming solar energy is 100%, 30% of it is reflected as the planetary albedo, some from the atmosphere, some from the Earth's surface. 19% is absorbed in the atmosphere and 51% is absorbed by the earth, by the land and ocean. Now once this energy, it becomes the part of heat, this heat transfer, it may happen by either of the three mode of transfer: conduction, convection and the radiation. So conduction will occur जहाँ पे भी हमारा टेम्परेचर अगर हाई है, उसके जस्ट कांटेक्ट में जो भी एयर मॉलिक्यूल्स हैं, they will become warm and they will transfer the heat to the other molecules. So next is the convection. Convection occur mainly with the help of water vapor. So when there is evaporation, some amount of heat is transferred into the atmosphere in the form of the latent heat. And then third is the radiation, means the earth, it emits the long wave radiation. So this radiation, either through the conduction, means this heat transfer either through the conduction, convection or in the form of the radiation, it is ultimately moving through the atmosphere. When this long wave radiation, जब ये atmosphere को pass करता है, then in that case some amount of this radiation is absorbed by the greenhouse gases. Now this greenhouse gases, ये वाला जो portion है, यानी कि यहाँ पे हमने जो देखा, this is a little complex, क्योंकि ये जो long wave radiation है, इसका कुछ portion directly space में जा रहा है, but कुछ portion हमारे जो atmosphere में greenhouse gases हैं, they absorb this long wave radiation and again they re-emit back towards the earth. And then again it will be absorbed by the earth, फिर से ये emit होगा, फिर उसका कुछ portion space में जाएगा, फिर से वापस ये earth की तरफ emit होगा. But ultimately if we calculate it for longer duration of time, तो ये जो absorb हुआ either in the atmosphere or by the earth, तो इसका 64% is emitted from the atmosphere, from the cloud or the atmosphere, and then 6% is directly emitted from the earth. तो अगर हम इसको बैलेंस आउट करें, यानी कि 70% is in the form of long wave radiation and 30% is reflected back. So the incoming solar energy and the outgoing solar radiation, if it is averaged out for the longer duration of time, तो ये हमारा बैलेंस होता है and thus maintaining the temperature of the earth. And अभी तक हमने जो भी पढ़ा, solstice and energy budget. So if you want to read in detail, you can refer this book, The Atmosphere, An Introduction to Meteorology. I have compiled the information from the books and from different websites. तो आप ये videos देखो and then you can refer to this one chapter in this book, and I think it will be more clear again. And if you have any question related to this, you can drop the question in the comment section. Thank you.